Openstax College Algebra. This video is about Chapter 2.1 Rectangular Coordinate Systems and Their Graphs from the Openstax College Algebra textbook. Download free at openstax.org. We will plot ordered pairs in the Cartesian coordinate system, graph equations by plotting points, graph equations with a graphing utility, find x and y intercepts, use the distance formula, and use the midpoint formula. Most larger American cities are laid out in grid patterns, and they represent the area of the original city, about 1 square mile. A 2,600-year-old Maya city has been found laid out on a grid. The city was in Petén, Guatemala, and there's also been an archaeological dig in Sindh province in Pakistan that's found a 2,500-year-old city laid out in a grid. Seems like a grid is something humans naturally understand. An example in the book. Tracy set out from Elmhurst, Illinois to go to Franklin Park. On the way, she made a few stops to do errands, and each stop is indicated by a red dot. So she stopped here at this intersection or this point on the grid, and then here at this point on the grid, and then again here at this point on the grid, and then again here at this point on the grid. We can see each stop aligns with the intersection of grid lines. So this particular one is on the intersection of North Avenue and Wolf Road. This horizontal and vertical line together is called the Cartesian plane, and it's named after René Descartes, the French philosopher and mathematician who first invented it. The horizontal line here, or arrow, represents the x-axis, and the vertical arrow here, or line, represents the y-axis. The story goes René was lying on his bed and watching a fly walk on the ceiling, and he realized he could use a grid pattern to mathematically locate the fly's position. In the middle, where the two axes meet, is called the origin. It's the 0 point on the x-axis and also the 0 point on the right axis. And notice we call this quadrant 1, and then we go counterclockwise. So this one's quadrant 2, quadrant 3 counterclockwise, or quadrant 4. In Australia, we say anti-clockwise. And we can use our grid here. If we place the numbers 1, 2, 3, 4, 5, they're the positive x values, -1, -2, -3, -4, etc. These arrows indicate this goes on infinitely forever. And if I want to locate a specific point on the grid, so I go along here, 3 along the x-axis and up 2 on the y-axis, and that gives me the point x equals 3 and y equals 2. And we call those the xy coordinate point. In this example, we're asked to plot 3 points. The first point is x is -2 and y equals 4. So I start at the origin and go to the left to where x is -2. Then from there, I want to go from x equals 2 up to y equals 4. And that gets me to the point in question. And it's this point right here, the point where x is -2 and y is 4. So to plot the point 3, 3, I go over here to 3 on the x, up to 3 on the y, and here's the point. X is 3, y is 3. And the final point, x is 0, so that's this point right here, and y is -3, so this is the point 0, -3. So note that when either coordinate is 0, that point must be on an axis. So if x is equal to 0, it's somewhere on the y-axis. If y equals 0, it's somewhere on the x-axis. We graph equations by plotting points. We plot the set of points to represent the equation. In this example, we have the equation y is equal to 2x minus 1. This is just a formula to give you a set of x and y points. This is why we call x the independent variable. We just make up some values of x. So if x is equal to -3, then I can do a calculation. I would say then y is 2 times -3 minus 1, y equals -7, and that gives me the point -3, -7. And I can calculate all of these points here. when x equals 0. Y is equal to 2 multiplied by 0 minus 1. So the y point is -1 and the point in question is 0, -1. And you can see in this table here lots of different values of x. So they've just decided to start at -3, then -2, then -1, etc. And they've got all of these points. So remember, I chose randomly, well, it's not random, it's one by one, some x points, and then calculated the y points, and now I'm going to put in the points. So when x is -3, y is -7. So here's my first point. Then when x is -2, y is -5. When x is -1, y is -3. When x is 0, y is -1. When x is 1, y is 1. When x is 2, y is 3. And when x is 3, y is 5. And all of the points in between these are also part of the graph of the equation y equals 2x minus 1. So, when I connect all those points, I get the graph of the line y equals 2x minus 1. Let's do this on the calculator. I'm going to hit the y equals button, and in y1 I want to put 2x minus 1. Second quit gets me back to the home screen. I want a picture of this, and I'm going to go to Zoom Standard. The standard window is -10 to -10 on the x and -10 to -10 on the y, and that gives me this line. It looks about correct, but I can also see some of these points. So I'm going to say second table set and start at -3 and go up by 1 and make sure it says auto, and then I will hit second table, and that will give me some of these points. X is -3, y is -7, x is -2, y is -5, etc. And again, if I want to see the graph, I can just hit graph. If I want to see what the window is, remember I did zoom 6, which is the standard window, and that gives me x is -10 to +10 with a check mark every 1. Y is -10 to y +10 with a check mark every 1. In example 2, we are asked to graph the equation y equals -x plus 2 by plotting points. So we're going to start with x equals -5. So when x equals -5, then y is going to equal -5 plus 2. And of course, that means y equals 7. So if I calculate all these points, and then I need to put them on my graph. So when x is -5, y is +7. So here's the first point. Then when x is -3, y is 5. When x is -1, y is +3. This is also a straight line. And we can connect all the points with a line, and that's the graph of the equation y equals -x plus 2. On the calculator, again, we hit y equals, I'm going to clear out the old equation, -x plus 2. Do not use the subtract key, only use the negative key. Second quit gets me back to the home screen. Zoom number 6, Z standard, gives me the standard graphing window, and that shows me the graph. In example 3, it says use a graphing utility to graph the equation y equals -2/3 x plus 4/3. A graphing utility just means a calculator like the TA84 plus color edition that I have here. So I'm going to hit the y equals screen. I'm going to use the -2 divided by 3 times x plus 4 divided by 3. And second quit gets me back to the home screen, but I want to get the same graph as they show you in the textbook. So I'm going to hit the window key. I've got to go from -6 to +6 on the x-axis. See how it goes from -6 to +6. Check mark every 1, and then -2 to +3 on the y-axis with a check mark every 1. If I hit the graph key, I will see the graph of my equation. There are times, especially when we're graphing a line, we'd like to find the x-intercept, where does the graph cross the x-axis, and the y-intercept, where does the graph cross the y-axis. To find the x-intercept, we set y equal to 0 and solve for x. To find the y-intercept, we set x equal to 0 and solve for y. Example 4 asks us to find the intercepts of the equation y equals negative 3x minus 4 and then sketch the graph using just those intercepts. So to find the x-intercept, we have to set y equal to 0. So we have y equals 0 and y equals negative 3x subtract 4. And I'm going to add 3x to both sides. So I have 3x equals negative 4. Divide both sides by 3. So that gives me x equals negative 4/3. Notice the intercept is always a point. It's minus 4/3 for x and 0 for y. So when x is negative 4/3 and y is 0, the intercept is about there. To find the y-intercept, we set x equal to 0 and solve that equation. So y equals negative 3 multiplied by 0, subtract 4, or y equals negative 4. So the y-intercept is the point where x is 0 and y is negative 4. So x is 0 and y is negative 4 is down here. This is the line y equals negative 3x minus 4. Of course, it goes on infinitely in either direction. The distance formula is derived from the Pythagorean theorem, and it's used to find the distance between 2 points. So this point here, we're calling the point x1, y1. And this point here, we're calling the point x2, y2. And this corner point is x2, y1. So this length right here is the absolute value of x2 minus x1, or the value a. This length is the absolute value of y2 minus y1, or b. Remember, absolute value is always a distance. So from our graph, we have this length here is side A, and this vertical length here is side B. Of course, the hypotenuse is length C, and from the Pythagorean theorem, we get c squared equals a squared plus b squared. We need to think about this in terms of the point here, and remember, this point is x1, y1, and this point here is x2, y2. So remember, the absolute value of some value, let's call it z, is the square root of z squared. So the absolute value of x2 minus x1 is going to be the square root of x2 minus x1 all squared. Now, also, I want you to remember that if I have the absolute value of x2 minus x1 all squared, that's just going to equal x2 minus x1 squared. And we'll need to think of this when we look at the Pythagorean theorem using these distances. We say the distance squared is equal to x2 minus x1 in absolute value squared, plus the distance from y2 minus y1 all squared. And of course, that means that our distance squared is just x2 minus x1 all squared plus y2 minus y1 all squared. And that, if we take the square root of both sides, we end up with this distance formula. Example 5, finding the distance between 2 points. Find the distance between the point -3, -1 and 2, 3. And we start by looking at a graph of the 2 points. We'll need to connect those points and form a right triangle. So this point right here is x is 2 and y is -1. So that's a 2. Now we'll need to think about the formula. I'm going to call this x2, y2, just temporarily, and I'm going to call this point here x1, y1. So I'm going to need to find the distance between x2 and x1. So the point x2 in absolute value is -3. Subtract 2, so that is the absolute value of -5, or a length of 5. And if I count the squares here, 1, 2, 3, 4, 5, I see this is a length of 5. Now let's change this and call this one x2 and y2. It's just arbitrary how I do this. And now I want to find the length y2 minus y1. So y2 in absolute value is 3, subtract -1. So that is the absolute value of 4, or just positive 4. And if I count the boxes here, 1, 2, 3, 4, I see this length is in fact 4. So remember, I want to find this distance, d, or the hypotenuse. So I have the two lengths and I want to find the distance between the 2 points, and I can use the distance formula here, although it's just exactly the same as the Pythagorean formula. So either way you think about it, it'll work. So this is the distance of the square root of x2 minus x1, well that's 5 squared, plus 4 squared is the distance y2 to y1. So the distance then is the square root of 25 plus 16, and that is the square root of 41. Now you are able to find an approximation for the square root of 41. If I said second square root 41, I can calculate that. It's approximately 6.4. But if I said the distance equals 6.4, that isn't true. It's approximately 6.4. But you know what? This problem didn't ask me to approximate, did it? It just said find the distance, which always means the exact distance unless you are asked to give an estimate. Example 6, finding the distance between two locations. So we're going to return to the situation introduced at the beginning of the section. Tracy set out from Elmhurst, Illinois to go to Franklin Park, and on the way she made a few stops to do errands. Each stop is indicated by a red dot in the graphic below. Find the total distance that Tracy traveled and then compare this with the distance between her starting and final positions. Sometimes that's called the distance as the crow flies. So the first thing we should do is identify the ordered pairs to describe each position. And if we set up the starting position at the origin, so she's down there at 0, 0, and then she's going to come up here and then take a right and end up at her second position, which is the position 1, 1. Next, Tracy goes from the position 1, 1 to the position 5, 1. Then she's going to move from 5, 1 to 8, 3, but she has to go along the roads. So she goes to here and then to here. And finally, from the position 8, 3, she arrives at her destination here at the position 8, 7. Each grid unit is 1,000 feet. From 0, 0 to 1, 1 is 2,000 feet, because there's 2 grid units there. From 1, 1 to 5, 5 is 4 grid units, so 4,000, etc. So we count all that up, we have 15,000 feet. Now there are 5,280 feet in 1 mile, so if we divide 15,000 by 5,280, we see that she traveled about 2.84 miles. Now we want to find the direct distance from the point 0, 0 to the point 8, 7. And you can see this makes a triangle. So this is our point right here, 0, 0. And this is our point up here, 8, 7. And this point right here, well, I can count 1, 2, 3, 4, 5, 6, 7, 8. This is the point x equals 8, y equals 0. So this point right here, x equals 8 and y equals 0. So this length of this side is 8. And the length of this side, 1, 2, 3, 4, 5, 6, 7, is 7 minus 0. So this length is 7. So now I can use the distance formula. So the total distance that Tracy drove is 2.84 miles, but it's not the actual distance between the starting and ending points. Remember, here's the starting point and here's the ending point, and we use the distance formula for that. And we see the distance is the square root of 8 minus 0 squared plus 7 minus 0 squared Square root of 64 plus 49, the square root of 113, or approximately 10.63 units. Well, 10.63 units approximately is going to have to be multiplied by 1,000 feet, because that's what the grid is in the graph. So that's about 10,630 feet. And we're going to have to convert that to miles. So when I divide that by 5,280, I get about 2.01 miles. So in order to travel a distance of 2.01 miles, she had to drive with her errands and all the rest of it. She drove 2.84 miles with errands. The midpoint formula can be found when we know both ends of the line segment, when we know the point. So this point right here we're going to call x1 and y1, and this end point here is the point x2 and y2. And if we want to divide this line segment exactly in half at exactly the midpoint, x coordinate will be x1 plus x2 divided by 2, and the y coordinate will be y1 plus y2 all divided by 2, and that will give me the midpoint, or this point right here. In example 7, we are to find the midpoint of the line segment with the endpoint 7, -2, and 9, 5. So you remember the midpoint formula. x1 plus x2 divided by 2 is the x coordinate, and y1 plus y2 divided by 2 is the y coordinate. So the midpoint here is x1, that's 7, plus 9 divided by 2, that's the x coordinate, and then for the y coordinate we have -2, which is y1, plus 5, which is y2, all divided by 2. So the midpoint here is 16 divided by 2, or 8, and 3/2, and that is this point right here, which divides this line in two. So this point right here is 8 and 1.5, or 3/2. Example 8 asks us to find the center of a circle, and it tells us the diameter has the endpoints -1, -4, and 5, -4. To find the center of the circle, we're just going to use the midpoint formula. So that means the midpoint x coordinate is -1 plus 5, all divided by 2. And the y coordinate is -4 plus -4, all divided by 2. So that is going to give us 4 divided by 2 all over -8 divided by 2. So the center of the circle, or the midpoint, is the point 2, -4. So the center here is the point 2, -4. And since I drew a graph to help us visualize this, you can see that that is in fact correct.